All right, welcome back. I hope you had a good spring break and are ready to finish out the year. We only have 2 months left and even less, as you know, because there's STAR and EOC and SAT and a bunch of stuff. So let's finish strong. Keep turning in your work, keep watching videos, and finish strong. Be done with Algebra 2. All right? We got a lot to do today, kind of, okay? Make sure you're paying close attention. There's a lot that encompasses the next week, okay? So we're starting with rational functions. We did that before spring break, but this time we are graphing. We're learning the graphing rules. We haven't graphed in a while, okay? It says a rational function is of the form f of x equals px over qx. And it says where px and qx are both polynomials and qx is not equal to 0. Okay, don't get confused on that. That's just basically giving us the layout. These are the rules. Step number 1 is simplify the function, factor if possible. We've been factoring now for like 3 months. We should know it by now. Then it says to get the x-intercepts, you set the numerator, which means the top one, equal to 0. Then we solve for x. I'm going to go through the rules. Then we're going to have our examples. Okay, so you're going to have to scroll back or refer back to this. Step number 3, y-intercepts. It says find f of x when it's 0. So basically plug 0 in for x wherever you see it and solve for y. We know how to do that. Here's where we get to maybe some new words, but I don't want you to be scared. It shouldn't be too bad. It says vertical asymptote or vertical asymptotes. Set the denominator equal to 0 and solve. The graphs never cross a vertical asymptote. And it says there can be none, one, or more than one vertical asymptote. And this is, it doesn't include holes. So today we're graphing without holes. Later this week, I got to look at the schedule, but I think we do graphing with holes. So we'll learn that. But all day today, there's no holes. Then, step number 5, horizontal asymptotes. We look at the degree, the highest exponent. Degree means highest exponent. Hold on. All right. The pledge is about to happen, but I'm going to get as much in as I can. So it says look at the degree, the highest exponent of the numerator and denominator. If it's bigger on bottom, y equals 0. If it's bigger on top, there is no horizontal asymptote. And it says eats DC. Exponents are the same. Divide. Hey, good morning. Here we go. All right, I'm back from the pledge. Sorry about that, y'all. I know I left off on eats DC. It says if exponents are the same, divide leading coefficients, and whatever you get, y equals that. And that would be the horizontal asymptote. And it says graphs may cross a horizontal asymptote, and also there cannot be more than one horizontal asymptote. All right. Then it says step number 6, the domain is all real numbers except those that make the denominator equal to 0. All right. That'll make sense in a second. Then it says holes. Number 7, holes. A hole appears in the graph when a factor appears in both the numerator and denominator, or they cancel out. That's the example. Then it says A, the x-coordinate, set the common factor equal to 0, and then solve. And then y-coordinate, substitute the x-coordinate into the simplified function and solve. Okay? Well, remember, all of these are important to do. We are graphing without holes, so we don't need to do step number 7. Okay? So let's start with example number 1. Remember, you're going to have to refer back to all those rules and all those steps. So example number 1, f of x equals 3 over x plus 1. Okay? I'm going to be switching colors a lot. Let's just start with red. The domain, as you see, it says rules, simplify the function, factor if possible, then to find the x-intercept. Let's go in the order of these rules, okay, not in the order of the example. Sorry about that, y'all. So to find the x-intercept, it says set the numerator equal to 0 and solve for x. So the numerator, remember, is the top one. So to find the x-intercept, 3 equals 0. That doesn't work. That doesn't tell the truth. So the x-intercept is none. So all we're doing is setting this, the numerator, equal to 0. Typically, there would be an x up there or something to do, so we would actually have to solve that equation. All right? Now, to find the y-intercept, it says find f when it equals 0. So we basically just plug 0 in wherever x is. So we have y equals 3 over x plus 1. All right, so this x is going to be 0 because the rules state find x, plug 0 in for x and solve for y. So we're going to plug 0 in for x and solve for y. That is going to be 3 over 1, which equals 3. So our y-intercept is 0, 3. So we have done the x and y-intercept already. Now, we're going to switch gears a little bit. We're going to look for the vertical asymptote. And as it says, to find the vertical asymptote, set the denominator equal to 0. So the denominator, which is down here, so x plus 1, that's plus, equals 0. So let's just solve for x. Get x by itself, minus 1, x equals negative 1. So our vertical asymptote, x equals negative 1. I want to stop here. Let's jump down to number 6. It says, the domain is all real numbers except those that make the denominator equal to 0. I want to read that again. It says the domain is all real numbers except those that make the denominator equal to 0. What did we just do to find the vertical asymptote? We set the denominator equal to 0. The reason I'm saying this is because the number for the domain right here is the same number as the vertical asymptote because we did the same thing for both. Okay, so the domain is x is everything except negative 1. So the domain number, the number for the domain right here, and the vertical asymptote will always be the same when we are graphing without holes. Keep that in mind, okay? So when you find the vertical asymptote, immediately put it as the domain as well. They are the same number. All right, so now we only have to find the horizontal asymptote. And the way we find that, it says just look at the degree. I'm going to switch colors just because. It says look at the degree. So on the top, I'm going to write it over here, 3 over x plus 1. Remember, degree means basically where x's are because it means the highest exponent. So on the top, do we have an exponent or an x at all? No, we don't. Do we have one on the bottom? Yes. The degree down on the bottom is 1. So it's bigger on bottom. So when it's bigger on bottom, we see it's bow. So that's going to be a 0. So when it's bigger on bottom, y equals 0. So the horizontal asymptote is 0. Now we are going to try to graph it, okay? Taking all the things we just filled out, we're going to graph it. We see the vertical asymptote. I'm going to switch to green so it matches. The vertical asymptote is negative 1. Watch this. Here's negative 1, right? I'm going to draw a little dashed dotted line down here. That is not a part of the graph. Everything else is where the graphs will be, the lines will be. So this is how it looks. Let me switch colors. My graph is going to be red. The first part looks like this. It does not touch negative 1. The second part, remember, we don't have an x-intercept, so make sure none of it crosses this x-axis right here. There's no x-intercept, but there is a y-intercept. The y-intercept is 0, 3. So we know it needs to pass this. All right, so I'm going to draw up above here. I'm trying not to let it pass negative 1. It's harder for me than it will be for you. Bring that down here. Oops. I cannot draw, y'all. That's why I teach math. And it comes here. All right, that is our graph. That is how it looks. So the vertical asymptote is negative 1. So we draw a little dotted line down through negative 1 to make sure we know the graph does not pass negative 1. It never crosses negative 1. All right, and that is it for number 1. All right, I will do one more because I know I don't want to take up too much of your time, and I know it's a lot. All right, so I'll do example number 2, and then you're on your own. Let me know if you have any questions. Like I said, I know it's a lot. That's why we're going to do one more and one more only. All right, moving on. Let's start with the x and y intercepts again. To do the x-intercept, set the numerator equal to 0. So the numerator is the top one, x equals 0. Well, that's easy. We don't have to solve anything. Sorry. X equals 0. We don't have to solve anything. Then x-intercept is 0, 0. It's telling us x equals 0. All right. Then the y-intercept, plug 0 in wherever x is. So 0 over 2 times 0 minus 3. That's going to be 0 over whatever, negative 3 or 0. So the y-intercept is also 0, 0. All right, so we already have the x and y-intercept. Let's find the vertical asymptote. And remember, we do that by setting the denominator equal to 0. So 2x minus 3 equals 0. Let me switch colors. Sorry, I don't want us to get mixed up. Make that green. 2x minus 3 equals 0. Plus 3 plus 3. That's 2x equals 3. What's the last step to get x by itself? Divide by 2. Divide by 2. X equals 3 over 2. All right. So our vertical asymptote is x equals 3 over 2. Again, like I said up there, the domain and the vertical asymptote are the same. So if it's 3 over 2 for the vertical asymptote, the domain is 3 over 2. All right. Then lastly, to find the horizontal asymptote, look at the degrees. So up top we have 1. We have x over 2x minus 3. That is 1x up top over 2x. All right, it eats DC, so the exponents are the same. It says the exponents are the same, so divide the leading coefficients, and y is the number. Basically, what that means is since the exponents are the same, at the top we have 1x, and on the bottom we have 2x. So our answer is just 1/2. Do you see what I'm saying? Here, the exponents are the same. They're the same on the top and the bottom. So then we have to look at the coefficients. These are coefficients. We get 1 over 2. So our horizontal asymptote is 1/2. All right. So let's graph it now. This one's going to be a little bit tougher only because we're dealing with fractions. Vertical asymptote is 3 over 2, which is about 1/2. So we go to positive 1/2, and I'm gonna draw my little dotted line. Again, I'm not an artist. Just try your best, okay? Then our horizontal asymptote, think about it. Vertical is up and down, horizontal, left and right, is a positive 1/2. So again, look where I'm going. Again, not an artist. Oops, I didn't become dotted. There we go. So that's how it's going to look. So we know one part's going to go about right here, and then the other one's going to go on the bottom. All right, so let's try to graph it. We see the x and y intercepts are 0, 0. So we know it crosses 0, 0. Here is 0, 0. So we know the graph goes like this. All right. And the other side is just easily here. Make sure it doesn't cross the asymptotes and you did what you were supposed to. So here, notice I didn't use any calculator at all. You have to be able to find this stuff yourself and then just graph it based on the numbers you get. Okay, it shouldn't be too bad. Like I said, I know this one was a little long, okay, about 15 minutes, but it shouldn't be that bad. Refer back to it if you need to, okay? Complete the worksheet, get it done.